surveyor has taken the measurements shown in the figure below. Find the distance across the lake. Round to the nearest tenth. Okay, well, it looks like we have a triangle, so that's good. And instead of solving for the whole triangle, we're really just solving for this distance across the lake here. We want to put some angle names and side names in here to help us use some of the formulas with which we're familiar. So for lack of a better idea, we got, how about A, B, C? We could call them alpha, beta, gamma if we want to, right? You'll see different examples. This is fine too. Now that we have our angles in place, we just want to make sure we're being really careful of what we call these things. So this will be little a, this will be a little b, and this will be a little c here. Okay, so it looks like I am wanting to find a side, okay, and I'm given two other sides and an angle. So when I look at, say, when I look at law of sines, what do I need for law of sines? I need an angle, so I need like an A and an angle and a side, and an angle and a side. When I'm looking at law of cosines, I need some angle and then all the sides. So what do I have here? I have two sides and I'm looking for a third, okay? And I know one angle. So if the thing I am looking for, so here's the thing I'm looking for is a side. If that were the case over here, then I would need to know these three things. And that means that I would need to know two angles. Not that it's necessarily impossible to find out somehow, but that doesn't seem like our best option. Let's look over here. Here I'm looking for side A. Now, do I have its opposite angle? Yes. And the other two sides? Yes. So this tells me that law of cosines, it's going to directly solve for my A and just be done with it. Perfect. Okay, solve for A. And up here I could put something like, let A represent distance across the lake. In feet. Okay, solve for A. So if I'm solving for A, then I know that, let's see, what's the angle I want? I want A because that's the one I know. So I'm going to have cosine of big A down here. That means little a finds its spot here. And then this is going to be b squared plus c squared minus 2bc. Boom. All right. Now, if I'm searching for a, well, that's good because I'm basically already solved for this. So I've got a squared. So a is just going to be just the square root of all this stuff. Okay, easy enough. Let's plug that in and then we'll pull in our calculator. So let's see, B we said is 800, C is 900, and then these values just show up one more time, 800, 900, and then cosine of 70 degrees. Boom. So we really just have to put that kind of big old mess in our calculator. So I'll pull in Desmos, and I'm going to have square root, so I'm going to have 800 squared plus 900 squared minus 2 times the 800 times that 900 times cosine of 70. This is giving me 978.5. What do I want? Nearest tenth. Okay, 978.5. So A is approximately 978.5 feet. And then whenever we do a problem like this, we want to answer in a sentence. So I would say the distance across the lake is approximately 978.5 feet.